Today's topic is petrochemicals. I need to do a little introduction before we actually get to the petrochemicals, but we'll start as follows. First is that every molecule of carbon can be attached to 4 other molecules, and there's a term called a carbon chain, is a situation where we have lots of carbon molecules attached one to the next. So they just line up one to the next. Now, in those chains, each carbon will be attached to 2 other carbons. So it has 4 things that it can attach to. So typically it'll attach to 2 other carbons, and then the other 2 open spots, so to speak, will be other molecules of hydrogen or oxygen. That's a typical carbon chain. Now, sometimes 2 of the carbons will be what's called double bonded to each other. So instead of them using up one connection, they have a double connection to each other, which means then each one of those have now used up, so to speak, 2 of their connections with the carbon next to it, and they only have 2 open things to attach to something. They can only attach to 2 other things instead of 3 other things as the other ones would. Now, many of the things that are chemicals that are used in food production, like alcohols and fatty acids and esters and things, all those kind of names like that, are made from these carbon chains. So what's the difference between one and the next? The difference is how long the carbon chain is. Some of them have branching to them. Does the chain just straight, or does it branch off into different directions? How many carbons there are, how many double bonds there are, how many oxygens there are. So all these different factors mean that one thing is not the same as the next, and they have all these different properties, one for the next. So that's general about carbon and carbon chains. Now, there's a specific type of carbon chain, which is called a carbon molecule, which is called a hydrocarbon. So a hydrocarbon means it has just carbon and hydrogen. Okay, no oxygen, no anything else, just hydrogen carbon. So that's why hydrocarbon, or just hydrogen carbon. So crude petroleum, what we'd call oil coming out of the ground, is this viscous black liquid, and it has all different types. It's a mix of many different types of hydrocarbons. So when you refine petroleum, the first thing you do is you use a type of distillation to divide this mix of hydrocarbons into different fractions, different groups, so that the length of those carbon chains in each group will be different because they have different properties. So there's a couple of main groups that there are, and I'm going to say them in the order of how many carbons they have to them. There's natural gas. The next is naphtha or gasoline, like you put into your car. That's like that fraction. Jet fuel, otherwise known as kerosene. Diesel, and then the ones with the longest chains are lubricants. So, these fractions are these fractions of this, like the kerosene and the diesel, have nothing to do with people around the Hashgachah. No one cares whether the diesel fuel is kosher or not kosher. But what we're going to talk about is chemicals that are made from these materials, not fuels. Okay, companies that do this, that refine petroleum, they're fuel and chemical companies. A lot of what they do turns into fuel, and a lot of what they do turns into these chemicals, and that's what we're going to focus on. Okay, now another introduction is I need to just explain some nomenclature, and that is scientists have their own language that's very specific in the way that they describe a chemical, and they use these terms because that way they could each, so to speak, understand each other. They use a term and everybody knows what it means. Okay, and so what happens is I'm going to mention some of those things that are going to be relevant for what we're talking about, and that is the beginning of a chemical's name for the case that we care about, the beginning will describe how many carbons are in the chain. So we're going to care, for our purposes, about 4 of those names, and that is the first 4. Does it have 1, 2, 3, or 4 carbons? If it has 1 carbon, it'll start with a meth. 2 carbons will start with eth. 3 carbons will start with prop, and 4 carbons start with but. Okay, and I'm going to give an example in a second. Let me just say what the next part of the name would be, and then I'm going to come back for an example. The next will talk about how are those carbons bonded to each other. So for our purposes, we have 2 choices. We could have ane or ene. Okay, that's ane or ene. Ane means that there are no double bonds. So we would say methane. Well, methane not such a great example for this case, but we would say butane. That means it has 4 carbons, and ane means there are no double bonds. So those 4 carbons are lined up, each bonded one to each other, and all the rest of the spots are, since it's a hydrocarbon, are filled up with hydrogen. There's nothing else in it, just straight a bunch of carbons, and all the rest of the spots are hydrogen. If it would be ene, like we would say ethene. Okay, ethene means eth means it has two carbons to it, and the ene, the end of that term, the ene part of it, tells us that there's a double bond. There is at least a double bond. Well, in this case, it's just two carbons. So obviously we know what the double bond is between those two carbons. When that word ethene is actually very important for today's discussion, and that's because colloquially we call those ethylene. The technical term would be ethene, but everybody calls it ethylene for whatever reason. And the same for propene. Propene would mean three carbons with at least one double bond. So one of those is bonded to each other. For our purposes, it's not important which one it is. And it's propene would be the technical term. It means there's one bond. In practice, everyone calls it propylene. That's like the colloquial way, so to speak, of speaking to it. Now, there's also, so that's the core of the name. This thing is propene or ethane or something like that. There are also prefixes and suffixes that go onto these chemical names that tell us something else about the molecule. The one that would be relevant for us in this discussion is a suffix which is the end ol at the end of the word, like ethanol. So ethanol means eth means that it has two carbons. The an tells us that it's an ane, that there's no double bonds here, and the ol tells us something else about this molecule. And that is, in this case, we're not so important what that means, but it means that there's something else called a carboxyl group. That's a certain type of chemical molecule attached to a carbon chain that would not be, of course, in a hydrocarbon, because we wouldn't have that. Carboxyl groups have oxygen in them. But for our purpose, that wouldn't be an example of a hydrocarbon. But there could be a molecule called ethanol or methanol, and that means it's this many carbons. This is how they're bonded to each other, and it also has something else stuck onto it, something else attached to it. The group, it's not just a chain; it has something else. In this case, it has this carboxyl group. Okay, so now let's move on. But when we have there are three groups of materials that are made from petroleum. I'm going to talk through each one of them briefly. They're called alkanes, olefins, or alkenes. Those terms are interchangeable, and aromatics. Okay, now alkanes, the term comes from the fact that it has the ane in it. That means that these are going to be hydrocarbons with no double bonds in it. Okay, so the alkane is the shem kali. It's the group name for hydrocarbons that have no double bonds and has the ane term in it. So we might say methane or ethane or propane or butane. Okay, so those are all that many carbons that there are, and they're aned. It means that they have no double bonds. Okay, and all those are parts of the natural gas that you get out of petroleum. So that's one group of materials that would come out of petroleum. A group of chemicals that come from petroleum. The next is the alkenes, or olefins, they're also known as. Alkene is a shem kali for things that have that ene end of the name. That means they have some kind of a double bond. Now, the hydrocarbons that you find in petroleum have no double bonds in them. By nature, there are no double bonds in them. So we get how you could have alkanes, but how do you end up with alkenes? So what happens is, the first step is, as I mentioned, the refinery will take the crude oil and separate into the different fractions. And part of that is they remove out all kinds of things that don't belong, like sulfur and nitrogen. Again, we want just hydrocarbons, just hydrogen and carbon in these chains. They get out things like sulfur and nitrogen. They have a name for it. They're called, I hope I pronounce this right, heteroatoms. Anything that doesn't belong in a hydrocarbon. And let me just mention for a second how they do this. The process to get all those other chemicals out is called hydrotreating, or otherwise known as hydrogenation, which involves that you use really high heat, like 600 degrees Fahrenheit, tremendous amounts of pressure, like 200 psi, and a catalyst. And all of that is done. The petroleum or the petroleum fraction is heated. All of that with a lot of hydrogen in the vessel. And what happens is it causes that all these heteroatoms, all these things that are not hydrogen and carbon, will be replaced in the chain. They will leave the chain and be replaced by hydrogen. So it's a way of purifying the hydrocarbon and taking, let's say the nitrogen or the sulfur or whatever else might be mixed into there and getting it out. And what will happen is, or the oxygen, and what will happen is those molecules that left the petroleum will regroup into something else. So let's say the the sulfur will interact with other hydrogen and become hydrogen sulfide, or the oxygen that's in there will mix with the water and become with the hydrogen turn into water, H2O. And then we could separate those out. Okay, so anyhow, this is the process called hydrogenation. It's basically saturating, filling everything with hydrogens, and not saturation is the wrong word, but filling everything with hydrogens and getting rid of all the other molecules. Anyhow, so after they did that, the fractions with the smallest carbon chains, after they took this what came out of the oil and turned it into just pure hydrocarbons. Well, the parts with the smallest carbon chains are going to be natural gas that has between 1 and 4 carbons, different mixes. So it'll have ethane and methane, different mixes into it, and something called light naphtha that's within the group of naphtha that has the lighter parts of it have 5 or 6 carbons in them. So we have this. Now we have these items that have these relatively short carbon chains and the pure hydrocarbons. Then what they'll do is they take ethane, that's the one with 2 carbons in, and it has no double bonds. Take ethane and light naphtha, and they crack it. I'll explain cracking in a second. They crack that item to create ethylene or propylene or some other alkenes. Again, so they're taking a hydrocarbon that has no double bonds, and through this process of cracking, they're all of a sudden taking these shorter chain carbon chains, again, basically between, they're taking either ethane that's 2 carbons or light naphtha, which is 5 or 6, and they're turning it magically into something with a double bond into it, using this cracking. Okay, what's cracking? Cracking is, what you do is you take a hydrocarbon, you heat it under really high temperatures, like 1400 to 1700 degrees Fahrenheit, to the point that the molecules break apart. Okay, in the cracker, the machine that you use for this, there may also be steam and catalysts that help the process along to go faster, and also make sure you get the right things coming out of the cracker and not something else. And not only does it cause chains that are larger to get smaller, physically, to crack from bigger size to smaller size, but also it causes some of those. It peels away some of the hydrogens from those molecules and creates double bonds. So all of a sudden you go from ethane to ethene or ethylene, okay? Or we end up with propylene. The ethylene is the main thing you're getting out of this, but there's also propylene and some other alkenes, other olefins that come out of there, all kinds of types that come out of there, okay? Now, just as an aside, at this very high temperature, these things are obviously very flammable. These are all petroleum-type products, but there's no oxygen, so there's no burning. We'll get back to that in a second. There's no burning. Nothing burns in there. It just has this reactions that happen. So that's our second group of items, that chemicals that come from petroleum. And our last group is called aromatics. And these items, they're called aromatics, but they don't necessarily have an aroma. For whatever reason, I don't know why they have that name, but the feature of aromatics are that they have the carbons are there, which the carbon chain, instead of being a straight chain, like, so to speak, lined up one next to the other, they wrap around to become a ring. Okay. Not only do they turn into this ring structure, which is called like a benzene, that's what it's called, into this ring structure, but half the bonds between the carbons that are in this chain are double bonded to each other. So basically every other bond is a double bond and every other is just a single bond. Okay. So what the simplest of the aromatics is actually called benzene, and that is, it has 6 carbons. It has 3 double bonds, as I mentioned, and 6 hydrogens, which is to say each of the carbons is double bonded to one carbon, single bonded to another carbon, leaving only one spot open to bond to it, and that bonds to one hydrogen. So there's ended up being only 6 hydrogens in this molecule. Actually, if you want to know the technical name, I'm going to spell it out. That benzene is just what we call it, and the ene tells us that there's double bonds here, but that's not the formal name. The formal name is actually cyclohexatriene, and that means it's cyclo because it has this ring shape to it. Hexa means it has 6 carbons. Tri means there are 3 watts, 3 double bonds. Ene, tri-ene, 3 double bonds. And that's the technical name, but no one calls it that. Everybody calls it benzene. So there's also 2 variations of benzene. Benzene is the base of aromatics. There are 2 variations. One's called toluene and one's called xylene. Those are benzene rings, but they have either 1 or 2 what's called methyl molecules attached to the ring. So the ring doesn't just have a hydrogen attached to it; it has a methyl, or 1 or 2 methyl molecules to it. Okay, so anyhow, the point is we have this different kind of molecule. It's an ene and has double bonds to it, but it's different than the ones we talked about in the alkenes. And these are created by what's called pi gas. It's really, the technical name is really pyrolysis gas, which is to say is when you crack and there's no oxygen available, what happens is this cracking. So it's a result of that cracking is the main thing you get out of it is the alkenes, the olefins, but you also get some of these what they call aromatics, the benzene, xylene, and toluene. Okay, so now that I've told the three groups of items that come out of the out of petroleum, the three types of chemicals that are made by petroleum, the alkanes, the alkenes, and the aromatics. Now we're going to move on. Now, some of these things that I just mentioned could be used actually as is in an industry. There's actually a food application for one of them, which is a person who distributes fruit. He gets it from the farmers. They might harvest the fruit when it's not ripe, and then fumigate it with these tiny portions, like 100 parts per million of ethylene, and that causes the fruit to ripen. It turns out that some fruits themselves produce ethylene to help with the ripening. So distributors will mimic that by taking fruit that's not ripe, purposely picked when it's not ripe, and right when it's about to come to market, they fumigate it with this chemical, the ethylene that came from the petroleum, and it will help ripen it just in time for it to come to market when people want to buy it. Okay, but the truth is that most of these things are not used as is. The ethylene and propylene, ethane, the things that are made from it are not used as is, but they have all types of other use, as I'm about to describe. So these chemicals that I talked about that are made from petroleum, you could use them, you could lengthen them, like turn them into polyethylene, take ethylene and make a lot of them attached to each other to make polyethylene. It's a type of plastic. You can combine them with other things, other chemicals to make combinations that have some value to them, or you can alter them. Take it from an ethane to ethanol. Okay, that's altering. You're taking this thing that was just ethane, and you turned it into ethanol. You attach this carboxyl group to it. So that's not the chemical itself. It's chemical that's been altered. But anyhow, most of the things that you can make out of these are plastics and other things that are inedible. Okay, so it comes from, again, so that for Kashrus reasons, we don't really care about the Kashrus of PVC piping comes from here, or acetone, that's a nail polish remover, or polyester, or epoxies. All those are made from ethylene and propylene and some of the other chemicals I spoke about above. And again, from a Kashrus perspective, that's not a relevant. It's not relevant to us where it came from. It came from petroleum, but no one cares whether their PVC pipes in their housing, in their plumbing, is kosher or not kosher. But there are. And now here we get to the food part of this. There are many items that are made from there that are used in food production. Okay, not most, but there are many that are. And I'm going to give, about 6-7 examples, maybe it's more than that. Okay, I'm going to do them in alphabetical order. Glacial acetic acid and acetaldehyde are made from ethylene. Okay, ethylene is one of these chemicals I mentioned before. They're used for reactions, and the two of them, glacial acetic acid and acetaldehyde, respectively. Glacial can be used to produce butter flavors, and acetaldehyde is used in apricot flavors. Those are just some examples. They could be used for other flavors also. So then benzaldehyde is a flavor chemical. It gives an almond taste to foods, and it comes from toluene, which is one of the aromatics. Or butyraldehyde is made from propylene, and it gives a banana flavor. Okay, so you get the feeling here of what's going on here. So these are all coming from these petroleum-based chemicals, or petrochemicals, and here they are. They're being used in foods. Ethanol is used as a solvent. It's a solvent in and of itself. It's also used as a raw material to make other flavor chemicals like ethyl formate, which gives a raspberry-like flavor. Well, the ethyl part of that molecule, the ethyl formate, comes from ethanol, and very commonly that would come from petroleum-based. And the ethanol can be made from ethylene. Okay, now they're not the same. Remember, ethene or ethylene is just the molecule, 2 carbons with a bunch of hydrogens around it, with 2 carbons with a double bond and a bunch of hydrogens around it. Ethanol has only one, has no double bonds, and it has this carboxyl group attached to it. So it's a different molecule, but it could be made out of ethylene. In fact, it often is for these types of uses. Okay, then ethyl acetate is another example. It's used as a solvent. It's also used as a flavor component. It gives a fruity pineapple-like taste, and it is, of course, as with the previous one, it's made from ethanol. Well, then now to a little different one is methyl butyrate. It gives a sweet apple taste, and it's made from reacting methanol with butyric acid. Okay, well, methanol and butyric acid could be made methanol from methane and butyric acid from butane. Okay, those are both alkanes that come out of petrochemicals. And my last example here is propylene glycol. It's a food grade item. It's used in all kinds of places in food, and it's made propylene glycol. Guess what it's made from? It's made from propylene. Okay, which is one of the alkenes that I mentioned above. So to summarize over here is that the bulk of these things of what is made from petrochemicals are inedibles, things that have no food type application. But as I gave you these bunch of examples, there are many that in fact are food grade. Now, for most of the things that we talked about, petroleum was and continues to be the simplest and the cheapest way to make these ingredients. So they don't pose a Kashrus concern. There's no issue. It's made from petroleum. In plants that all that they do is make petroleum type items. No problem. Everything was fine. Really very good for the people involved in Hashgachah. However, the people in Hashgachah, want to keep their eyes open to say, let's just make sure things stay the same. And in fact, things change here and there. So one change that happened a couple of years ago, the company started making propylene glycol from glycerin. And of course, that's very important because here propylene glycol is assumed to always be kosher. Glycerin could be made from non-kosher animal fat. So that's a pretty serious possible concern. At that time, everyone believed that any propylene glycol made in this more complicated and expensive way would be specially marked, and people would price it accordingly because they're selling a product that has some special features that somebody might want. So standard propylene glycol stayed as a group 1 that didn't need Hashgachah because it was assumed that it came from petroleum. Well, there's an example. But in recent years, there's been a lot of push from the market and from government incentives for companies to reduce their carbon footprint and to use as many renewable, sustainable materials as possible. Well, industry has responded in many ways, but the petroleum industry has made changes either at existing petroleum companies or at new companies built specifically to create these type of items that people and government want the people to have, these renewable, sustainable items with less carbon footprint. So in all cases, whether they did it in an existing company or at a new company built special for this, the idea is the same. You take something that's non-petroleum and you convert it into a hydrocarbon by taking out these heteroatoms and reconfiguring molecules so they should look like the same ones that you find in petroleum. Okay, they take something that's non-petroleum and they do different steps to it to turn it into essentially what would come out of petroleum. And the starting material is going to be something that has basically no market use to it, like plant materials, wood shavings, used cooking oil, or animal fat. Okay, now the first two of those aren't sensitive kashrus-wise, but the last two, used cooking oil and animal fat, are obviously not kosher. Now, a lot of the things that they make out of these renewable sources ends up being fuels, like biodiesel, or something inedible like plastic. But just like petroleum, lots of it ends up that way. But some of it ends up in the food chain. Now, to make things even more complicated, the industry allows companies to use credits, which means to say is if I make one thing with a renewable raw material, I now have credit of having made items with renewable materials, and I could transfer that credit to something else that I made from petroleum. So, a minute ago I told you about the glycerin that was made from, the propylene glycol. The propylene glycol that was made from glycerin. The special propylene glycol is actually the one made from glycerin. In this case, we have no idea which is the one that was made from the renewable and which one is just called made from the renewable, but it never actually was. It just you have a credit. They legally it's called made from renewable material, but it wasn't really. And I'm going to give an example of that. There's a legacy petroleum producer. They've been making petroleum products for a million years, and they started using a small percentage of used cooking oil in their process, and they use it to create diesel fuel. Okay, well, they didn't have that worked well for the process they were doing was to use this to take the used cooking oil and convert it into diesel fuel. Well, but they didn't have any financial benefit to sell renewable diesel fuel. That didn't, for whatever reason, that wasn't financially worthwhile to them. What they did, they took the credits that they had for producing using renewable raw materials, and they transferred it from the diesel to their ethylene production using something called mass balance, whatever that means. So that's not too complicated for today. They switched it. They transferred the credits from the diesel to the ethylene. And now this ethylene that they were transferring to was made from petroleum, 100% petroleum, no renewable materials in there. But they could still call it renewable because they transfer the credits from here to there. Well, it's making it even more complicated at this company is they transport their ethylene from one facility to the next. And from the place where they produce it to where they have to further process it, they use a pipeline. Well, that pipeline is not theirs. The pipeline is shared with other producers. So that means is that the ethylene that they take out of the pipeline, which they're calling renewable, is not even the same ethylene that they put into the pipeline. They put in ethylene they put in ethylene into the pipeline that they called renewable. It wasn't really renewable. It was only technically it was legally called renewable, but it wasn't really. It was just transferred credits to it. And then what they pulled out of the other end of the pipeline wasn't even the ethylene they put in. It was somebody else's. It could have potentially been somebody else's. I mean, the chance of theirs is just as much as anybody else's. So the thing that they were selling as renewable in the end product that would be sold as renewable, for sure did not come from used cooking oil. Not from their plant or any place that had nothing to do with it. So that sounds like good news. Well, the opposite, but it's also true, that there are going to be molecules or items that are sold they're being sold as if they're petroleum based, but it's not true. Those actually were made from used cooking oil. So here we have all these items, all these things that are made from petroleum that have always been assumed to be group 1. They don't need Hashgachah because the processes made, the raw materials are innocuous, and the process is always made in these companies that's all they do is make petrochemicals. But in fact, we've now banged into the fact that people are starting to, use animal fat and use cooking oil and similar things that do have Kashrus concerns. So there are possible reasons why that is not a Kashrus issue. Even if it was made from animal fat, magically the finished product might be kosher. That's way beyond the scope for our discussion today. So for this part, I just wanted to bring up that point, explain what these petrochemicals are, why they generally are assumed to be group 1, but why some of these new changes that have come about might potentially affect that status in the long term.